First, we find the critical numbers of this function that lie inside -2, 2. For critical numbers, we find the derivative and set it equal 0. Okay, so derivative is 3x squared minus 12x plus 9, and we set the derivative equals 0. That is 3x squared minus 12x plus 9 equals 0. Okay, now we solve this equation for x. Trinomial 3, 12, 9. We can factor 3 out, so x squared minus 3 times 4, 4x plus 3 equals 0. Okay, 3, we can divide both sides by 3 and get rid of 3, so x squared minus 4x plus 3. So trinomial, let's factor this x squared, so x, and 3 times 1, 3, to get negative 3, negative 1. Okay, and x, either x minus 3 equals 0 or x minus 1 equals 0. From the first factor we get x equals 3. From the second factor we get x equals 1. So 1 and 3 are the critical numbers of this function. This is a polynomial, so we don't have to look for other critical numbers, but we want to consider only, those critical numbers that lie inside -2, 2. 3 is outside of this interval, so we don't want to consider this one. Okay, all we have to do now is evaluate the function at these x values, endpoints, and the right critical numbers. So that's 1, -2, and 2. So we want to evaluate the function, not the derivative. Evaluate the function at the endpoints of this closed interval and the critical number, and at the critical number that is inside here, this one. So corresponding function fx. Okay, let's take the calculator out and evaluate this function at 1, at -2, and 2. I would graph this function. Okay, and second trace, that is calculate value. You can go for table, enter. Now x equals 1, 6. If you plug in x equals 1 here, you will get 6. Plug in -2, -48. Plug in 2, we get 4. Okay, so out of these three numbers, 6 is the largest one, so absolute maximum, and -48 is the absolute minimum. So absolute max value, that's 6, or sometimes you can write one location and the value 6, and absolute minimum value, that's -48, or you can go for -2, -48 final.